Hi, I'm Neil from Titan Robotics.
I'm Aiden.
And I'm Helena.
Today we'll be talking about our robot for the Titan Robotics Design Challenge.
Because of the COVID 19 outbreak, our team decided to focus on skills for the future that we could work on at home. One area that we decided to work on was our team's CADing skills. In order to do this, we created a challenge to design an outreach robot that could shoot 7-inch power cells onto a 10-foot high basketball hoop. The robot had to have a maximum frame perimeter of 80 inches, a minimum of 1-inch ground clearance, and it could have a maximum height of 30 inches with a maximum 12-inch frame and vertical extension. In addition, the design must include an RSL mount, as well as space for electrical components and the battery. Participants were put into groups of 3 to 4 and were judged based on the effectiveness of the design, the accuracy, quality, and completeness of the CAD, kid-friendliness and safety, and aesthetics and general appeal.
Here we have our four-wheel drivetrain. On the back are two smooth grip wheels, and on the front, two omni wheels to allow us to turn faster. The back is powered via four Neo motors run through two gearboxes, one here and one here. The front wheels are also powered by a belt that goes through this piece of square tube here. Also on this drivetrain, we have the main breaker here, which is basically like a big on and off switch for our robot, and the battery here. All of these supports are used to hold up things like our intake and indexer.
As a result of the limited space on the drivetrain due to specifications, we designed the intake to go over the bumper. It features 3 sets of intake rollers with 2-inch wheels, which are driven by a Neo motor. Another motor on the side of the intake allows for movement between the starting and active positions, ensuring it stays within the challenge specifications the entire time. The sides are made of Lexan, which allows them to be manufactured by us.
So this is our indexer assembly. So the way it works is that whether or not balls are taken in from the intake mechanism or they are dropped in from the player station, balls will basically be funneled in through this Lexan ramp attached on these pieces of cut 80/20. After balls are funneled in, they will basically enter this feeder system where they will be pulled up by these orange pieces of pilot belt attached to these 3D printed pulleys that will spin around these pieces of hex shaft to basically lift the ball up into the shooter. So the way this feeder system works is through the electrical board being connected to the SparkMax, which connects to this Versaplanetary with a Neo. When the Neo is activated, it will basically spin this connected system of timing belts that are attached onto these 18-tooth pulleys. So that when they spin, the top pieces of hex shaft will basically spin the poly belts, causing the lower hex shafts to also spin with it, in order to allow the ball on both sides to be carried up efficiently.
This is our shooter. It has three main components. First is the turret, which allows the entire shooter to spin around. That's powered by this motor here and a sprocket with chain. Next is the adjustable angle for the hood. That's powered by this motor here with chain on this sprocket. That moves this piece up and down so we can adjust the angle of our arc. Finally, the most important part of the shooter is the flywheels. The flywheels take a ball in from the indexer and push it along these arcs really fast so that it shoots out of the robot. The Neo motor here powers that via a belt from this pulley to this pulley.
So here is our electrical board. The main electrical board is basically riveted onto the side of the indexer assembly, and it is protected by a Lexan sheet that is bolted in at these four corners with churros. When we were designing our electrical board, we wanted all the components of electrical to basically be in the same or like general area so that everything was easy to access and easily connectable. So that includes even parts that are not attached onto the main electrical board, that being the main breaker, battery, and RSL. The main breaker and RSL are basically attached onto extended brackets of other subsystems, and the battery is basically bolts It's not bolted. It's connected to a bolted-in C channel. And to provide extra security, it will be bungeed around through a bungee cord that will go around these two pieces of cut 80/20.